All right. Okay, so you can record.
Yes, sir. I have started it already.
Okay, so let's share it again, and then we can do it. All right. So sample space, actually, what is sample space? Before going to that, we need to know what is the outcome. Now, an outcome of an experiment is any possible observations of that experiment. So I am tossing a coin. What are the possible outcome? Either head or tail. So these head or tail, these are the outcomes. Okay, so possible outcome of the experiment is the outcome. Now, what is a sample space? Look at the definition. The sample space is the finest grain, mutually exclusive, collectively exhaustive set of all possible outcomes. Okay, so the thing is, sample space is, there are three specific criteria. One is very important, mutually exclusive. Another one is collectively exhaustive. The third one, the crucial one, is the finest grain property. Finest grain. We'll come in detail about finest grain, but look at the mutually exclusive. We already know what is mutually exclusive, isn't it? And also we know what is collectively exhaustive. So when several samples will make a sample space, and those samples are mutually exclusive, that means there are no overlapping, and also they collectively exhaust the space. So those samples, if combinedly they make the whole list of samples, then that sample space or that space will be called as sample space. Let's solve it by an example. Example 1.2. Flip a coin 3 times. Observe the sequence of heads and tails. So if we have 3 coins, first toss will give us either head or tail, second toss will give us either head or tail, and third toss will give us either head or tail. So how many number of combinations can be possible? First one, say for example, it is head, second one it is tail,
There are 8 possibilities.
third one it is tail. So there are 8 possible combinations actually, from tail, tail, tail to head, head, head. So there are 8 possible combinations that are possible in this space. So now if I say that sample space S is all these possible combinations like this, then that is called the sample space. The sample space is containing all the possible combinations. So they are collectively exhausting. And also, is there any common, common thing between them? Common thing means, are two samples same? No, there is no overlapping. One sample and other sample, these are not same. All are different samples, unique samples. Can you say what is the probability of THH?
1 by 8.
1 by 8, very good. So this is the probability of one particular sample, because every sample is unique and equally likely. So the probability of any sample is 1 by 8. So that is called a sample space, where there is no overlapping, and combinedly they're making the whole sample, whole, you can say the universal set. So that is called the sample space. Now, what is the finest grain property? Actually, it will be more clear when we will see event space. Actually, finest grain is something like you are having the information of all the samples. I mean, when you are, you can individually say in first toss, which one came first, head or tail. So every little information about the experiment is there in the sample space. But when you are talking about event space, you will see that these finest grain properties are not available. Okay, so let's see another example. Example 1.3. Flip a coin 3 times. Observe the number of heads. Remember one thing, first experiment and the second experiment are the same, but the sample space are different, because in the previous one you're talking about the observe the sequence of heads and tails. That was the objective, but now we are observing the number of heads. So number of head means from these samples we will find out how many number of heads are there. So in the first sample TTT, how many number of heads are there?
0.
Zero. Very good. This one, how many heads?
1.
1.
One. This one, how many heads?
3.
3.
Three. So there is a possibility that there can be two as well, isn't it? So the number of heads can be 0, 1, 2, 3. Can be 4?
No, sir.
No. So the maximum number of head is 3, and minimum number of head is 0. So look at this. The sample space in example this 1.3 is 0, 1, 2, 3. So these are the outcomes. These are the outcomes. And with these possible outcomes, we are making a sample space. And this sample space is containing how many heads are there. Okay. So this sample space is containing all the possible informations, not a set of information. From this one, actually, this is the exhaustive set of information. Okay, so this S is containing the samples directly, not by a set of samples, but the samples itself directly. Okay, someone is giving me a message. Let's see the message first. Okay, you can go, Irfan. You can go. Okay, also roll number 36 to 36, you can go and come back quickly. Okay. Anyway, so the thing is, so I think it is clear now. Now from the example 1.5, what can we see? Manufacture an integrated circuit and test it to determine whether it meets quality objectives. The possible outcomes are accepted or rejected. So I am testing a circuit, or I'm testing a chip, and what can be the output? Either you will accept it or you will reject it. So the sample space will be A or R. Okay. Another example, they have shown that this is a noise. So the noise with a time varying noise, and definitely T is a real value. So there can be how many value of noise? Can you tell me?
Infinite.
Infinite number of noise is possible. So this sample space will contain infinite number of samples. Okay. So that is the case for the sample space. Now let's go to the event space to make it more clear. Now the thing is event. What is an event? This is very important. What is an event? Event is a set of outcomes of an experiment. Remember one thing, this is not just outcome. Sample was something that's an outcome, but the event is not the only outcome. It is a set of outcomes of an experiment. So actually, I am experimenting something, and then out of all the outcomes, I am taking some outcome and making a set, and that one is an event. And by taking set, I'm making different events, and taking all these events, if I'm making a event space, then I am telling whether that will be an event space or not. That particular definition will be this one. Event space is a collectively exhaustive, mutually exclusive set of events. So I am taking some events. If I am combining them, not all the time they will make event space. They will make event space only then when those are mutually exclusive events, That means there is no overlapping, number one. Number two is they will be collectively exhaustive. Those events will combinedly make the whole sample, all the samples, or make the universal set. Then I will say those events are a member of the event space. Let's make it more clear. Example 1.6. Okay. Suppose we roll a six-sided die and observe the number of dots on the side facing upwards. We can label these outcomes where I denotes the outcome 1, 2, 3, 4, 5, 6. That I dots appear on the up face. So actually we are rolling a dice and we are getting either 1 dots or 2 dots or 3 dots or like 6 dots. The sample space for this S equal to 1, 2, 3, 4, 5, 6. No problem. No problem regarding the sample space because I have found the samples like 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, 6 dots, and we can make a sample space. But what will be the event space? Then we have to make some events. What are the events? Number one event is roll 4 or higher. So I will choose only those samples whose outcomes are 4 dots or higher. So how many samples are possible?
3.
3 because 4, 5 and 6. So the event E1, this is one event which are containing these samples 4, 5, 6. Now event E2, in the event E2, what is that? They're telling this is the roll is even. So those outcomes which are even in number, they will be the part of this event E2. How many samples will be there?
3.
Again 3. What are they? 2, 4 and 6, isn't it? So these 2, 4 and 6, they will be the number of samples in this event E2. Now I'm talking about E3. E3 is another event where the roll is the square of an integer. I mean, we know that the square of an integer is what? 1 is a square of an integer, 1 is square. 4 is a square of integer, that is 2 is square. 9 is an integer of square, 3 is square. Then 16, that is 4 is square. But our outcome is only 1, 4 is possible because there is no 9 dots or 16 dots. So the events E3 will contain only 1 and 4. Is it clear to all?
Yes, sir.
Yes, sir.
Can you repeat again?
Which one? The last one?
Yeah, the event E1 and from there. The E1, even E1, event.
Okay. Event E1 is what? What I'm finding, look at that. In the face up, actually what is that? This is the dice. And we have some dots here, isn't it? And then
Yes, sir.
2 dots here, 2 dots here, say 3 dots here, 3 dots here. In the and then 4, 5, 6. There are 6 combinations possible, isn't it?
Yes, sir.
Now I am rolling a dice, and I am talking about those samples which are 4 or higher. What are these?
Oh.
4 or higher. How many combinations can be there for 4 or higher? Let's say, for example, this is 1 dot where it came 4. 1, 2, 3, and 4. So I'm finding 4 dots in the face up. This is the up face. Okay. So in this case, it is 4 or higher. Another case, it is possible where 4 or higher. That is what?
5.
5. Very good. 5. If there are 5 dots, there is also 4 or higher. Another is there. What is that?
6.
6, right? So the sixth also, if I do that, 6, also 4 or higher. So
Okay.
this 4, 5, 6 is the member that is a part of this event E1.
Okay.
All right.
Yes, sir.
For E2, the role is even. Which are even? In 1, 2, 3, 4, 5, 6. 2, 4,
2, 4,
6.
6.
Right. And then who are the square of integer? 1 is a square of integer because
Five.
it is 1 square. This is square of integer because it is 2 square.
2 square.
There is nothing in the 1, 2, 3, 4, 5, 6 other than
No.
this 1 and 4 who is a square of some integer.
Okay.
Now tell me, E1, E2, E3, can they make event space? Very important question. Anyone? Can they make event space?
No, sir.
Why
I
not?
don't think so, sir, because
You said there are some common events.
Sir, they are not mutually exclusive.
Right, because they are not mutually exclusive. They have some common. Look at this. This 4 is common in these 2 or also in this 3.
This year.
So they are not mutually exclusive. Also, one is enough, but I am telling you, they are not collectively exhaustive as well because 3 is missing. Okay, so this event E1, E2, and E3, they are not making an event space. Now, can we make an event space? Say, for example, E5. E5 is something which is the uh, odd numbers. Odd numbers. So, then what are the event members?
1, 3, 5.
1, 3,
3.
and 5. And I'm telling E6 another event which is the even numbers. What are the events? What are the
2, 4,
members?
6.
2, 4, 6.
2, 4, 6. Now, can we say that E5 and E6 is the member of an event space?
Yes, sir.
Yes, sir.
We can say that because they are not mutually exclusive. Also, they are collectively exhaustive. So, we can say that this event space ES is equal to E5 and E6.
E6.
Okay, so this one actually we can say that. Remember one thing, what is the difference between event space and sample space? In the sample space, there was another condition that is
Finest
finest
grain.
grain property. What is that? Remember one thing, in the sample space, we can have all the qualities of the sample. We can know about what sample are there. But from event, can we say about sample? No, we can say only about events, not about samples. What are the event E5 contains? It is not given here. It is not clearly mentioned here. So in the event space, we cannot be sure about what are the samples are, or the sample finest grain property are not explained in the event space. But in the sample space, the finest grain property is there. In the sample space, we have 1, 2, 3, 4, 5, 6. We can say there are 6 outcomes. We can say what are the outcomes. But from the event space, we cannot know what are the outcomes and what are the what are their values. We cannot know. Okay, that's why event space and sample space are different. Okay,
Okay, sir.
all right. Yes, roll number 235. You can go for Asr prayer, but you have to come back very quickly. Maybe you can I don't know. Maybe you can go a bit late. Anyway, it's up to you. If you go to
So when are you finishing the class?
the 5,
5. Okay.
maximum 5. Okay, maximum 5. So the thing is, uh, uh, we can understand what is the difference between event space and family. look at the finest grain property. Individually, we're telling this one because look at this. Flip 4 coins, and then you're finding some head and tail. So we can have the sample space like this one, where 4 tail to 4 head combination is possible. How many possible samples are there?
16.
16 or 2 to the power 4. Okay, so 16 possible samples are there. Look at that sample space. I can understand what are the outcome and which one has in the first toss, which one came in the output. We can also tell that by seeing every sample. Okay, so in the sample space we are getting this 4T and 4H, all the possible samples, and we can do that. But in the event space, look at the event BI. What is it telling? Outcomes with I heads. Outcomes with I heads. What does it mean? Each BI is an event containing one or more outcomes. So what do you mean by B1? B1 means I equals to 1. It means outcomes with I heads. That means one head. One head is possible, like, say for example, T, one head. Okay, one head means
Triple
do
TH.
and do. Say for example, H, T, 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 or T, H, T, T, or something like this one, isn't it? B0, there is a B0 as well, 0 head, and that one will be T, 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 isn't it? And similarly, B2 will be there, B3 will be there, B4 will be there as well, isn't it? So these are some events. Remember, these are some events. And remember one thing. In this, when I'm talking about that B is a sample space or event space which contains this B1, B2, B3, B0 and B4. Okay. This event space is containing only the events, not the samples. I cannot say that I know that this B1 is carrying a single head, but that head came in which toss, we cannot know, isn't it? That's why we cannot know this finest grain property from this event space. We can get some property, but not all the properties of the samples. So this is the difference between sample space and event space. Clear?
Sir, it means we do not know exactly which B1 we're getting. Like we may get HTTT or THTT.
Right,
So
right,
this is
right,
the thing.
right. So
Okay,
we
sir.
know that B1 is a single head, but we don't know which time it came, the single head. Either it is the first toss or second toss or third toss or fourth toss. We don't know. Do you understand?
Yes, sir.
Okay. So these are the finest grain property elements. Now let's see this theorem 1.2. Look at this one. The thing is, for an event space B equal to B1, B2, B3, B4, and any event A in the sample space, actually remember one thing, event space and sample space, even if we have some difference, but the area or the boundary line of the event space is the same as the boundary line of the sample space, isn't it? So even this is a sample space boundary. This is the same as the event space boundary. Okay, so we have a event space where B1, B2, B3, B4, several events are there, and you can understand if B1, B2, B3, B4 events combinedly make the event space, actually they are mutually exclusive, isn't it? So there is no boundary, there is no overlapping between B1, B2 and B3 and B4. Okay, so they are telling A is another event in the sample space, and I am superimposing this A and this B. So this A is actually like this, and CI is A intersection BI. That means C1 is A intersection B1. Similarly, C2 equal to A intersection B2, C3 equal to A intersection B3, like this one. So what is C1? Intersection of A and B1 means what? This area, isn't it? Do you understand?
Yes, sir.
And then C2 is what? Look at this. This C1 is already given here. This is the C1. What is C2? C2 is the A intersection of B2. So we have A and intersection of B2 means this one. So if I draw this C and B2 intersection, that will be actually this one. So that one is the C2. Look at this. This is the C2. Similarly, C3 is what? B3 intersection A. Again, this one. Okay. So that one is C3. This one is C3, like this one. And then we're talking about B4. B4 is this one. I mean, B4 intersection A is C4, and that will be this one. So the theorem 1.2 is saying if the event space and event A is like this one, then the events C1, C2, C3, and C4, they will follow two rules. Number one rule is they will be mutually exclusive. Number one. And number two is their addition. I mean C1 plus C2 plus C3 plus C4, or you can say C1 union, C2 union, C3 union, C4. That will give us the event A. So this whole area will be actually A. Actually, we can easily understand that that will happen because B1, B2, B3, B4, they are mutually exclusive. So their part will also be mutually exclusive. That's why C1, C2, C3, C4 are mutually exclusive. Number two is we are breaking the B1, B2, B3, B4 in 4 different parts according to A. So if I combine these 4 different parts, that will again find A. That is the logic, isn't it? So this theorem 1.2 is saying that if in an event space I superimpose an event A, then if the C values are coming from A and event space B1, B2, B3, B4, then these C values, if I add, they will again make A, and also C1, C2, C3, C4, they are mutually exclusive. Is it clear?
Yes, sir.
Yes, sir.
Okay, then we can go for the next slide. There is a classwork. There is a classwork. Now you do it very quickly and very carefully. Very easy classwork. I can give you 2 minutes to solve it. Quick. I'll ask.
Sir, I have missed the instructions, sir. Can you repeat again?
What is instruction? Everything is given here.
No, sir. Actually, my doorbell rang and I went for a while.
There is a classwork given here. Solve it.
Okay, sir. Sir, shall I give the answer in chat box?
You find the solution. I will ask.
Okay, sir.
When you finish, please let me know. It's very easy. If you can try, you can find it out. Okay, I'm asking. Roll number 170021059. Fayyaz Zarif.
Yes, sir. Yes, sir. Yes, sir.
Can you tell me the answer of the question number 1?
It's A1.
A1. A1. What is the answer of this A1?
Sir, it will be, sir, VVV, VV,
VVV.
and then VVD,
VVD.
then, sir, VDV,
VDV.
and, sir, VDD.
VDD. Why don't you write in your notebook?
Okay, sir.
Everyone, write in the notebook. You have to use the pen and pencil. Every day when I make the class, then you have to bring the pen and paper with you, so that you can directly tell the result to me. If you answer now and if you find out your own answer, then it will not be good. So the thing is, you are right. Okay, you are right. Your roll number is 059. Okay.
Yes, sir.
Okay. Now, roll number 204. Anika, are you there?
Assalamualaikum, sir.
Walaikum salam. Can you please answer the question number 2?
Sir, I'm trying.
Why are you trying? Haven't you finished it in your room? You're supposed to finish this one. When I'm telling to solve it, it means you will solve it in your room.
Sir, I was having some net problems. I couldn't see it. Sir, it will be DDD,
DDD,
DVD,
then
DVD,
DVD,
DDV,
DDV,
DVV.
DVV. Okay, very good. Very good. So your roll number is Anika. Anika Hanuma. No, Anika Enam.
Yes, sir.
Okay, roll number 204. Okay. Okay. So now roll number 214. Ashik Billah.
Sir, Assalamualaikum. Sir, he just called me that his current just went off now.
It is his bad luck because I was giving some numbers, you know.
Yes, sir. He just called me
Yes,
now.
okay, no problem. No problem. No problem. Now I'm giving 180021247. Omar 247.
Yes, sir.
Okay. Can you please answer the question number 3?
Question number 3
Yes.
is VVV, VVD,
Okay.
DVD,
Just me.
and
Second call is the
DVV.
voice call. Okay, so you are talking about what? Can you tell it again?
Yes, sir. Yes,
Tell it
sir.
again, please.
Is VVV,
VVV,
VVD,
VVD,
DVD,
DVD,
DVV.
DVV. Very good.
Yeah.
Very good. Very good. Yes, very good. So your roll number is 247.
Yes, sir.
Okay. Thank you very much. So for today, actually, Actually, I think you can answer all the questions. So try to solve this problem. This is from the book, so solve it by yourself. And remember one thing: when you are finding A1 and B1, also you need to find out that whether they are collectively exhaustive and mutually exclusive or not. Previously, what we have found, that one and that one actually collectively exhaustive and also mutually exclusive, isn't it? First call is a voice call, then some combination, and then first call is a data call, then some combination. So these two are, there is no overlapping between these two. So they are mutually exclusive and collectively exhaustive also, because combinedly they make the full list of outcomes. Okay, so solve it by yourself, this 1 3 5 7 2 4 6 8, and then also compare between 3 and 4, 5 and 6, 7 and 8, like this one. Okay, so complete the full example, and then maybe in the next class I will check whether you have done it or not. Is there any question?
No, sir.
No, sir.
Okay, so I'm hopeful that you can understand what I'm giving the lecture. So it will be able, you will be able to understand it more clearly, because if you go through it in the room, so when you are not in the class, maybe you can go through the book. Okay, you can go through the texts as well. You can go through the quiz or chapter exercise, and you can make it more clear how this set theory works, how these event space, sample space work, and you can solve it inshallah. Okay, thank you very much. Now I'm giving you the roll call.